Okay, so this time we'll try to simplify a few problems in logarithm. Now, this question says if log 4 in base 2 plus log 7 in base 2 minus log n in base 2 equals 1, find n. Very simple problem. All we need to do is to apply the laws that we learned in the previous lesson. So we remember that one of the laws has it that when you have addition of separate logs to same base, you can pick them and take the product together. So it simply means that this is going to be log base 2 multiplied by, sorry, 4 multiplied by 7. So this is it. Then we have minus log n. Okay, so in this case, we can also do the same thing for the subtraction part. Remember, we can add it up. We can make it to become a fraction. So this is now going to be log 4 times 7 divided by n, all in base 2. So this is basically how we apply the laws of logarithm. You see, what initially appeared as a very complex equation is now simplified. So this at the end of the day is going to give us log 4 times 7 is 28. So we have 28 divided by n in base 2, giving us 1. Very simple. Now, what's the next thing I need to do in this case? Remember, one of the laws has it that in the logarithm of numbers having both the same base, and for example, we're working with log 10 in base 10, it gives us 1. Log 2 in base 2 gives us 1. Log 5 in base 5 gives us 1. So because I have 1 here, I'm going to try to pick the logarithm of 2 to base 2. Why did I decide to pick 2? Because of this particular 2 here, so that I can have the same basis and then they can cancel out each other. So that's just the smart thing to do. So we have log 28 over n in base 2 give us log 2 in base 2. So you see, remember, the log of a number to same base gives us what? 1. So that is what we didn't do anything. We only just smartly did that. Now, what do we do next? Since we have log to the base of 2 and log to the base of 2, they can cancel out each other. And then I'm going to be left with 28 over n equals to 2. Of course, the normal thing to do here is we can simply just cross multiply. When I cross multiply, I'm going to be left with 2 times n equals to 28 times 1. And that gives me 2n equals 28. Then I'm going to have to what? Divide both sides by the coefficient of n, which is 2. And then my answer becomes 14. So the value of n from that equation is 14. So that is it. The next problem we'll try to simplify is saying log 49 raised to power a in base 7 minus log 0.01 in base 10. In trying to simplify this 49 is actually a perfect square, so I can take it to 7 raised to power 2. So I'm going to write log 7 raised to the power of 2. And of course, multiplied by a. So log 7 raised to power 2a in base 7 minus, well, this is log 0.01. Now, 0.01 is actually 10 raised to power minus 2. When you express this in standard form, that's what you're going to get, 10 raised to power minus 2. Then we move down to this side. One of the laws, if you remember, I think the 5th law or so that we treated when we're talking about the laws of logarithm, we said that whenever you have a power, okay, the power can be moved to the front of the log, then you will be left with whatever you have there. So we're going to apply that law now. It simply means that this expression is going to become 2a log 7 in base 7 minus, this is minus 2 as a power 2. So I'm going to move it to the front. It becomes minus 2 log 10 in base 10. Also, trying to bring your mind back to one of the laws we treated. We said when you have the logarithm of a number to the same base, it gives you 1. So it simply means that log 7 base 7 is 1. So this is going to be 2a times 1. While this is minus times minus is plus. So this is going to give me plus 2. While log 10 to base 10 is also what? 1. So this is simply 2a plus 2 when simplified. There's nothing else you can do. So this is your final answer. So it's very simple. Now we're going to quickly look at the next example we have here. Example 3. We have log 1.44 minus log 90 to base 10 plus that. Okay, so this is a very straightforward problem. All we just need to do is to apply the laws that we've been working on. So this is simply log base 10. This and this, their connection is addition. So we have to multiply them in a single form. So it's going to be 90 times 0.025. Okay, 90 times 0.025. Then the next thing we do is to what? Oh, sorry. This is supposed to be okay, let me take it the other way. Sorry, this is going to be, since this is minus log 90, so 90 is going to be in the denominator, actually, not numerator. Sorry about that. So this is going to be log 1.44 times 0.0625 divided by 90. So that's the right thing to do. Now, when this is multiplied, when we multiply this and divide by this, we're going to be getting a number 0.001 in base 10. So you could decide to punch your calculators to confirm this. So this is, remember, this is 1.44 multiplied by this. Now, 0.001 can also be expressed in standard form, and that's going to give me log 10 raised to power minus 3 in base 3. Now, this is minus 3. Okay, remember one of the laws, that's the logarithm of a number with power. The power moves to the front. So this becomes minus 3 log 10 to base 10. Also, we talked about the logarithm of number to the same base, it being equal to 1. So this is log 10 to base 10 is going to give me 1. So this simply means that I have log minus 3 times 1. And then my final answer is minus 3 when this expression up there is simplified. So that's what we get. And finally, we want to express 2 log x in base 2 minus x log 1 plus y in base 2 equals 3 in a form not involving logarithm. So what we need to do is to remember one of the laws where we have to move the power to the front. So I'm going to try to move from back to front this time. So this time, this is simply going to become log x squared in base 2. I hope you remember that law. Then this is going to be minus log 1 plus y in raised to power x in base 2 equals to 3. Then also you remember the division law, okay? The division law that gives us subtraction. So we're going to move to that one. since we have the same base, so this is going to be log x squared. Remember, it has to be a single fraction over 1 plus y raised to power x equals to 3. Please do not confuse this. This 2 is supposed to be a base here. It's not the power of this. Okay, let me strike it off. This is not the power of this. It's actually base. So I'm going to move the base here. All right. Now remember one of the laws of logarithm we talked about that if, so let me write, recall that if log x in base a, okay, equals to y, it therefore means that a raised to power y equals to x. Okay, remember I told you that this is the law that connects indices to logarithm. Now, what we do? We're going to try to apply this same law. So it simply means that this expression is now going to turn into 2 raised to power 3 equals to x squared over 1 plus y, okay, raised to power x. Now, you have to also recall that 2 raised to power 3 is equal to 8. 2 raised to power 3 equals to 8. So that gives us 8 equals to x squared over 1 plus y raised to power x. Now I'm just going to try to cross multiply. And this is going to give me, I want to move to this side of the board. So this is going to be 8 into 1 plus y raised to power x equals to x squared. So there's basically nothing else you need to do here because the question says express that thing in a form not involving logarithm. So now we've succeeded in taking off the logarithm, and now this is what we are left with. So we've succeeded in simplifying this question. I hope you like the video and you've learned something. Please, if you've not subscribed, kindly do that. Thank you so much and see you in the next video.